Now that we've taken some time to learn what polynomials are, how to write them in standard form, we need to learn how to do some basic operations with polynomials. In this particular lesson, we're going to deal strictly with adding, subtracting, and multiplying. Now, if you've recall from your Algebra 1 education, you've probably learned how to do this, and you recall that specifically in adding and subtracting polynomials, you're doing what we call combining like terms. So if we want to combine like terms, it's just simply the process of putting two parts together that are the same. So if we add 2 plus 3 equals 5, that's combining like terms. And if we put variables with it, we're still just adding the coefficients and just carrying the variables along with it. So it doesn't matter what the variable exponent is, we would just simply carry that together. Now, if the exponents are different, then we do not have like terms and we cannot add those together. Now, we can do this in this method, which is kind of a horizontal method, or we can also do it in a stacked method where one is stacked on top of the other and we still get the combining of like terms there. So really, whether it's going up or down or side to side, it doesn't matter, and you really need to decide which method you feel more comfortable with. So if you look at example 1 here, you can see we have part A and part B. Part A is in a stacked method, and it's very important that you get the like terms stacked up on top of each other so that they are the same. Notice here with the x values, there was a missing x value, and so we left a little blank. Or you could simply write in 0x to get the same effect. Either way, but you need to have those lined up. Now, that makes it pretty easy to see the like terms and just to simply add or subtract, combine the coefficients. Now, if it's in a horizontal method, and specifically like this, you need to be very careful that you notice that addition between the two sets of parentheses so that you don't make the mistake of foiling. You would not foil in this manner. You would simply drop the parentheses and add the like terms. So, if we look at sample problem 1, we give you just a simple adding polynomials. We just need to combine like terms. Now, if you don't like it stacked, you're more than welcome to rewrite the problem in this manner, which is the same exact problem, and then you would just simply drop the parentheses and go on from there. I'm going to just go ahead and work it in its stack method. So 5 and negative 3 gives me 2, and of course I'm just carrying the x squared. Negative 6 and a positive 1 gives me negative 5x, and then negative 7 and negative 1 gives me negative 8. And so we have our polynomial there. It's written in standard form, and all the terms are combined appropriately. Now, subtraction gives us a little different scenario, so you can look at example number 2. With subtraction, what's required here is a little different. This negative or subtraction symbol should be applied to every term in there, thus leading us to this polynomial. Then you can simply combine the like terms as we did before in addition, but the subtraction must be distributed before. Again, here, subtraction between the parentheses, don't make the mistake of foiling these. You need to distribute this negative to all the parts inside before you would combine the terms. So subtraction is just one additional step over addition, just making sure that we distribute that negative value. So let's look at a couple sample problems here on the next page. Sample problem number 2. And be sure you're attempting to work these first before you watch me work them. That way you'll see what mistakes that you have. Alright, so the first thing I'm going to do is I'm going to distribute this. I'm going to rewrite the first term, and then I'm going to distribute the negative, and when I do that, I'm going to get a negative 5x to the third, a positive x squared. Notice I'm missing an x term, so I could simply put in a positive 0x there just to hold the place, and then negative 17. And then I'm just going to combine terms from here. So that's going to give me negative 2x to the third plus 9x squared minus x minus 22, and that would be my answer. Okay, and then we have a horizontal one here, so we're going to need to distribute this negative to all the given parts. So I'm going to rewrite the first term, and now I'm going to distribute that negative, so that's a negative 3x to the fourth plus 12x to the third, and plus x. Now the key here is making sure that you get all of the terms that are the same written together, and I'll look for an x to the fourth, and I have 9x to the fourth and I have negative 3x to the fourth, so I'm going to combine those to give me 6x to the fourth. Then I'm going to look for my x to the thirds, and when I combine those together, they actually cancel each other out. So the negative 12 and the positive 12 cancel each other out. Now I get to a situation where I have no more terms that are exactly the same, so I'm just going to rewrite what I have. So I have an x squared, I have an x, and I have a negative 8, and I want to make sure that I'll write those in the proper order for standard form. So there are a couple examples for adding and subtracting polynomials, either vertical or horizontal. Now that we've learned how to do basic adding and subtracting with polynomials by combining like terms, now we'll focus on multiplication. Now, multiplication of polynomials you should be familiar with from your foiling methods, although FOIL won't necessarily work for every type of problem that we're going to have. Now, if you look at example 3, you can see that we are working on this in a stacked method. So if you really think back to, say, your elementary school days, you've done a stacked method before. So if we had something like, 112 times, I don't know, let's say 15, you'll see here that we're going to take the 5 and we're going to multiply it times the 2 and the 1 and the 1, and so we're going to end up carrying the 1, and then we'll have 6, and then we'll have 5, and then the next part will require us to put a little 0 here or leave a little blank for a placeholder, and then we multiply the 1 times everything, and of course we combine the like terms, thus giving us the final answer. Well, basically we can also do polynomials like this. Now, if we look at example number 3, we have our polynomials in a stacked method. Now, I don't want you to be confused by this. This is just the multiplication symbol. That's not a variable of any sort, and so kind of like what we did here back in 3rd grade, so I don't want you to be confused by that. Now, what happens here is we follow the same protocol. We're going to multiply the 3 times every part in the top one, kind of like distribution, and that gives us negative 3x squared minus 6x minus 12. Then we're going to have this 0 as a placeholder, just like we did back in 3rd grade. Now this is very important because what it does is it lines up my like terms for me, which is the effect that we're trying to get. Then, once they're stacked appropriately, you would simply combine like terms like we did in the adding and subtracting part. And so this is very similar to methods that you've used in the past. So go ahead and try sample problem number 3 and then come back and take a look at it here in a second. Okay, so if we look at sample problem number 3, we're just going to go through this process of multiplying the 1 times everything on the top. And of course, 1 times anything is just simply itself, so I'm going to rewrite that. Then it's very important that I use a placeholder with a 0 there, and I will multiply the 2x times everything. So 2x times negative 5 gives me negative 10x. 2x times x gives me a positive 2x squared. And then 2x times 4x gives me a positive 8x to the third. Now we can see all of our like terms are lined up or stacked on top of each other. So it's simply just combine those like terms. 8x to the third plus 6x squared. And keep in mind that this is an understood 1. So that's minus 9x. And then a negative 5. And that would be our final answer. Now, that is an unusual way for you to probably multiply polynomials. Most of you are probably accustomed to seeing polynomials multiplied side by side. Now, you've been more comfortable multiplying two binomials per se, and that allows you to use the FOIL method. Now, FOIL only works for two binomials, and you have to be careful of this. But if you understand what FOIL actually is, you'll be fine. The foiling process just simply means to distribute each term. So if I distribute the x to both parts of x minus 3, and then I turn around and I would distribute the 2 to both parts, you've basically done the f and the o part here, and the I and the L part there for FOIL. Now, if you look at example number 4, FOIL doesn't work here because we have a binomial times a trinomial. But this same distributive process does work. So if I take the x and I distribute it times everything in there, which is what I'm doing with this step, then I take the -3 and distribute it times everything, which is what I'm doing in this step, then I get a whole bunch of terms scattered about that I just need to combine the like terms. And so multiplication is still just the distributive property. So go ahead and try sample problem number 4 by distributing both parts of the x plus 2 and see what you come up with. Okay, so we'll start by distributing the x. So x times 5x squared, so we get 5x to the third plus 3x squared minus 1x, and of course you don't have to write the minus 1, you can just write minus x. Then I'm going to distribute the 2, so that's going to give me 10x squared plus 6x and minus 2. And now I look for like terms, and so I don't see an x to the third anywhere else, so I write that first. And what I'm going to do here is, so that I write this in standard form, I'm going to go ahead and look for the terms that should be next in order. So I did x to the third as the highest exponent. Now I'm going to look for all my squared terms. So I've got 3x squared and 10x squared. So that's 13x squared. Then I'm looking for my x's. So I got x and x. So -1 and +6 gives me a +5x. And then lastly, my whole numbers. And that way I have it already written in standard form by taking it in that order. And so there's your final polynomial after multiplying. Okay, so now you've seen multiplying polynomials in a stacked method and a horizontal method as well.